Hey guys, so today we're going to just do this uh, a word problem in calculus. So this is a typical time, rate, distance, velocity kind of problem, word problem that you encounter in calculus. And what it is, I've got the statement of it right up above me there, and it's a car. So a car is traveling at 40 feet per second. Deaccelerates at a constant 5 feet per second squared. So 5 feet per second. And so every second it's losing 5 feet in velocity. How many feet does the car travel before coming to a complete stop? So I'll show you how to do it using traditional calculus, and hopefully I'll show you how to do it using a spreadsheet without any calculus at all in a separate video. So let me just go to my solution here. Okay, so first you need symbols normally for a word problem. So V for velocity, T for time is typical, and S for position. And to solve it, so you need to know how far does it travel. So you need the distance as a function of time. So we're going to get how many seconds does it take for it to come to a complete halt. And then once we have distance as a function of time, we can plug that in to the distance function to get the distance. So there's two different things. The seconds it takes for it to come to a complete halt, which is easier because you can use that. We can use the velocity function to get that. I think if you think it through, if he's starting out at 40 and he's losing 5 every second, after 8 seconds, his velocity will be 0. So actually common sense should tell you that. But so we use the function notation here where we say, the distance in parentheses, we put the independent variable. So the distance at 0 is 0. That's what we mean by S of 0 is 0. And the velocity at 0. So we usually start everything out with these problems at t equal to 0. So it's kind of implicit that the distance is 0 and the velocity is 40 at t equal to 0. So we'll use A for acceleration, and the acceleration, because it's deceleration, we use a negative, so it's negative 5 feet per second squared. So it's negative because it's going down. And so V of t will be our notation for the velocity. And the velocity is the antiderivative of the acceleration. That's where calculus first comes in. If you think of acceleration as the change in velocity, so acceleration is like the derivative of the velocity function. So if you want to go from acceleration to velocity, you're going backwards. It's the antiderivative. So you have to integrate. And it's an improper integral just to find the velocity. So it's the integral minus 5 dt. And the integral of a constant is just minus 5t plus an arbitrary constant c. But since v of 0 is 0, that constant has to be 40. So our formula for the velocity is v of t is minus 5t plus 40. And when is the velocity of 0? Well, you set that equal to 0. So you're finding t, so you have to set that equal to 0. You're setting the output of the function equal to 0. And so if we set v of t minus 4t plus 40 equal to 0, and you solve for t, you're going to get, in fact, just what we thought. T will be 8 seconds. So after 8 seconds, he'll be down to 0. He's going to start at 40, then 35, then 30. So what will be the distance? Well, we need distance as a function of time. So distance is s of t. We're calling that, again, function notation. How do we know that's the antiderivative of the velocity? Well, you think of velocity as change of distance. So velocity is ds dt. So velocity is the derivative of distance. So if you want to go back to the distance, you have to take the antiderivative of the velocity. And that's another improper integral. S of t is the integral minus 5t plus 40 dt. That's just the notation. Just use the rules for calculus, which is, finding the antiderivative of something to a power. So that's where we're getting that. The antiderivative of negative 5t is negative 5 halves t squared. The antiderivative of 40 is 40t. We always throw in a constant. Because s of 0 is 0, that constant is 0. So really our formula is s of t is negative 5 halves t squared plus 40t. So then to get the distance, we plug in 8 wherever we see t in that formula. So when we plug in 8, s of 8 is negative 5 halves. 8 squared is 64. And 40 times 8 is 320. And if you do the arithmetic, keeping in mind you have to do multiplication before addition, you're going to get 320 minus 160 or 160 feet. So that's the solution. And like I said, as I was doing this video, I realized there's a way to do it that's a little more pleasing to me. It doesn't even involve calculus. But let me go back to my main screen here. So that's it. So thanks, and probably see you if I do another one. We'll see.